In this question, I want to provide the solution to exercise level 2 question 4 from the series induction section of MEI Further Maths A-Level Core Year 2. So we're asked to prove by induction that the expression 3 to the power of 2n subtract 1 is a multiple of 8 for all positive integers n. And just to make the notation slightly easier throughout, I'm going to let this expression be equal to un. And we're going to proceed with our base case. So the base case, we are asked to show that this is true for all positive integers. So our base case is going to be the first positive integer 1. So when n equals 1, u1 is equal to 3 to the power of 2 times 1. So 3 squared, subtract 1, which is 9 subtract 1, which is 8, which is clearly a multiple of 8. Okay, so now we need our inductive step. And we are going to assume this is true for n equals k. So what are we assuming? We're assuming that uk, which is equal to 3 to the 2k minus 1, is a multiple of 8. And if it's helpful, we can say we are assuming that is equal to 8m for some m. And what do we want to show? Well, we want to show that it is true for n equals k plus 1, i.e. we want to show that uk plus 1, which is equal to 3 lots of 2, open brackets k plus 1, subtract 1, is a multiple of 8. Okay, so let's take our expression uk plus 1 and let's use our inductive hypothesis, this statement here, to show that uk plus 1 is also a multiple of 8. So uk plus 1 is equal to 3, and then if we expand out this bracket here, we get 2k plus 2, subtract 1. Well, this is 3 to the 2k times by 3 squared by our rules of indices. And now, notice we can take our inductive hypothesis and we can make 3 to the 2k the subject. So we get 3 to the 2k is equal to u to the k plus 1, which is equal to 8m plus 1. So making this substitution, we get u to the k plus 1 is equal to uk plus 1 times by 3 squared, subtract 1. If we expand this out, we get 3 squared lots of uk plus 3 squared, subtract 1. Well, that is equal to 9 uk. 3 squared subtract 1 is 9 subtract 1, which is 8. So we know clearly this term is a multiple of 8. And by our assumption, because remember our assumption was that uk is a multiple of 8, so this is also a multiple of 8. So the whole expression, 9uk plus 8, is also a multiple of 8. And just if you need extra convincing, if we let uk be a multiple of 8 and call that 8m, we get 9 lots of 8m plus 8. We can take our factor of 8, which is 9m plus 1. So clearly uk plus 1 is is a multiple of 8 if uk is a multiple of 8. So what have we done? We have shown that if n equals 1, un is a multiple of 8. And if un is a multiple of 8 for n equals k, then un is a multiple of 8 for n equals k plus 1, and so un is a multiple of 8 for all integer n greater or equal to 1. And it is worth pointing out that the question asked us to prove this by induction. However, there are other ways of proving this, and then we can prove this statement without induction reasonably easily. So let's take our expression un equals to 3 to the 2n minus 1. And notice that that is a difference of two squares. In particular, it's 3 to the n minus 1 multiplied by 3 to the n plus 1. And now notice that 3 to the power of n is always odd for n greater or equal to 0. And so if 3 to the n is odd, then 3 to the n minus 1 and 3 to the n plus 1 are even. And in particular, they are consecutive even numbers. Well, if we think about consecutive even numbers, exactly one of them must be a multiple of 4, and exactly one of them must be, and both of them must be multiples of 2. So, and that should be really clear if we just consider our even numbers. Let's take 2, 4, 6, 8, 10. Well, notice what have you got here is that these ones here, every other number are the multiples of 4. So what do we have? Well, we have one number what do we have? In our expression here, we have one number that is definitely a multiple of 4 and another number that is definitely a multiple of 2. So this definitely has a factor of 8. And to make this really clear, if we let 3n minus 1 be some even number, then notice that 3n plus 1 is equal to 2n plus 2. And therefore, 3n minus 1 multiplied by 3n plus 1 is 2n multiplied by 2n plus 2, taking a factor of 2, that is 4n and n plus 1. But if we have n and n plus 1, which are consecutive numbers, one of these is even. So we have another factor of 2 here. So one of these is even. So the whole thing is a multiple of 8 for some